Hello, my name is Alex, and in this video we're going to be building a full-stack cookie-based authentication flow, and we're going to be using Angular, Node.js, and MongoDB. Now, base knowledge in the three aforementioned technologies is required to follow along, but beyond that, let's jump straight into the video. Now, before we jump into development, let's take some time and look at the authentication flow. So basically, we begin with any request made from the client to the server. Now, first, let's say that the client wants to know whether it is authenticated with the server. So basically, the client will send an isAuthenticated GET request to the server. Now, the server will have to somehow know whether the client is in fact authenticated. So basically, let's say that the client is not authenticated, and it is the first time that the client is sending a request to the server. The server will create what is known as a session, and it will generate a dedicated cookie and attach it to that session. So basically, the first time the client makes a request to the server, it will not have any cookies associated with that server or that domain. So basically, let's say you're connecting to facebook.com and it is the first time you're doing so, and if that's the case, the client, aka your browser, will not have any cookies associated with the Facebook server. Now, the server will see that there are no cookies associated with your client, aka your connection. So basically, the server will generate a new session and a new cookie which will be associated with that session. Now, the cookie itself will have a name, a value, an expiration, and other parameters, while the session will have an ID, an expiration, and also other data associated with it. So basically, the first time you make a request to a server, a cookie will be generated on that server, and then that cookie will be attached to that session. So in this case, the session will have an ID, it will have an expiration date, and it will also have your cookie object attached to it. Then what happens is that the session will be stored on a database. So basically, since we're talking about an authentication flow and we need persistence, then obviously the session itself with the attached cookie will be stored onto the database. So at this point in time, the server will be able to look up the database and it will be able to see whether there is an existing session which matches the cookie that the client sends to it. Again, if this is the first time the client makes a request to the server, there will be no cookie, so it will not look up the database, and it will immediately generate a new cookie and a new session which it will store in the database. Now, that new generated session will have an ID, and the cookie will inherit the ID of that session. Next, the server will simply send the cookie to the client. So the session will only exist on the database and on the server, while the cookie is sent to the client. Now, the value of the cookie will be the ID of that session. This means that the next time the client is making a request to the server will simply look at the value of the cookie and it will be able to fetch an existing session from the database, and then it will be able to verify that session. Now, at this point in time, as you can obviously tell, there is no authenticated user. So basically we have a cookie and we have a session, but the only information that we have is that there is an existing cookie on the client which matches an existing session. Now, the reason why we create a cookie and a session even before the user logs in is that we can simply keep track of the existing connections to the server. So basically, let's imagine that we have 10 users connected to the server and we will have one session per user. Then if these users perform certain actions on your website and these actions are stored in some way, once these users log in, you will be able to associate the existing session with the login, and then you will be able to associate those actions with an existing user. This is very useful for gathering data and other purposes. So basically the idea here is that when the client first connects to the server a new session and a new cookie is issued. Now, every consequent request will not create a new session and it will not set a new cookie. You only create a session and set a cookie if prior to that an existing session did not exist. So essentially, a session helps to keep track of an existing connection. And no matter how many connections you will have a session for every single connection. Now, it is important to highlight that if the client goes and manually deletes the cookie from the cookie store and then makes a new request to the server will have no way to associate that new connection with the previous client. So basically, at that stage, the server will create a new session and issue a new cookie to the client. This means that the previous session will still remain inside of the database until it expires, and this is exactly why our sessions have an expiration date as well. So in essence, the server is in charge of creating new sessions, deleting old sessions, and issuing new cookies. If the user decides to clear their cookie store, as we've mentioned before, without the knowledge of the server, the previous session will remain until it automatically expires. So this is pretty much how a server can generate sessions and issue new cookies. So now let's see what happens in subsequent requests. So now let's go back to our flow here and let's see what the isAuthenticated request does besides setting a new cookie and creating a new session. So let's imagine that the client had some cookie and we want to see if that cookie actually has user information associated with it. Now the flow will be as follows. The client makes a request to the server and the cookie will be automatically sent with that request. It is really important to understand that all of your cookies will be automatically sent with your requests to the server. You don't need to manually send the cookies with every request, as they will be automatically sent as long as they're configured to do so. So basically, with every request, your cookie will be automatically sent to the server. So when you make the isAuthenticated request, alongside with your GET request, the server sees your cookies. It will then check if there is a session associated with that cookie, and if there is, it will check whether there is a user associated with that session. Now, obviously, at this point in time, we're not logged in, so it will not find any user associated with that session, so it will tell the client that no, you're not logged in. Now, when it comes to registration, things are very simple. So at this point in time, we're not logged in and we want to register. So basically, the client simply sends the registration data to the server, and the server checks the validity of that data and writes that data inside of the database. Then it sends a confirmation to the client, and the client redirects the user to the login page. So basically, at this point in time, we're not involving cookies. Now, the login flow is far more involved with cookies than any previous flow. So let's assume for a second that there is no authentication call, and basically let's assume that the login request is the first request that the client makes to the server. So basically the client sends the credentials to the server and the server contacts the database to validate those credentials. So far, so good. Next, just like before, the server creates a new session and a new cookie for that session. So basically, the server will generate a new session with an ID, an expiration date, and some other data. It will generate a cookie here, and then it will associate the ID of that session with the value of that cookie. So basically, we have a new session which only contains a cookie object within. However, in this case, we just verified that these credentials were valid through the database, and this means that we want to actually add a second object to our session. That object will be the user object and it will contain the ID of the user, which we just verified through the database, and maybe other information about that user. So from that point on, we can simply take that user object and also place it within the session, creating an authenticated session. So at this point in time, the session in question contains both the cookie object and the user object. So basically now we have a session here which contains both the cookie and the user object, and that session will be stored in the database. So the idea here is that from now on, we can associate a specific user with a specific section. Now here, just like before, when we want to set the cookie, we will set an expiration date, and then we will set the value of that cookie to the ID of our session. So nothing really changes from this step. So basically the logic is the same, and we're not including any user information within our cookie. Our cookie simply contains the session ID, and then it is stored on the client. So basically at this point in time, the client contains a valid cookie, and then with every subsequent request to the server, this cookie will be included automatically. So the server will see that cookie with every request the client makes to the server. Now, this is very important because at this point in time, certain endpoints and certain requests may require authentication. So basically, if we want to do an action which requires authentication, what happens is that we send the cookie back, the server checks the value of the cookie, so basically checks the value of the cookie, which contains the ID of some session. It then looks up the session in the database, and then it checks the user object associated with that authenticated session. So basically, it matches a specific user, and then it checks whether that user has certain permissions, or it may simply check that a user object exists within that session. And if it finds that the user exists within that session, it then responds positively to the client. So this is basically how the login flow works. Now, in our previous scenario here, we had already created a new session with a cookie, however, that session was not authenticated, so there was no user object associated with that session. Now, if we assume that this call is made before the login call, and then we try to log in, then we simply skip the step where we set the cookie and store the cookie. So basically, the idea here is that since a cookie already exists, the only thing we need to do is to modify our session to essentially include the user object into that existing session. So we're not creating a new session since one already exists, we simply modify the existing session. So basically, to recap, these are your two scenarios. In the first one, the request that you're making to login is your initial request, and this generates a new session, a new cookie, and a new user object. And then the cookie is being sent to the client. In the second scenario, you already have an existing cookie and an existing session, so you simply modify the existing session and nothing else changes. You keep using the same cookie and the same session, but the session itself is modified, and the modified version of that session is stored in the database. And now we're finally ready to talk about logout. Now, the logout request is pretty straightforward. Now, you can only log out if you have an existing session, which means that you have an existing cookie on the client. Now, with every request you're making to the server, you will be also including your cookie. This essentially means that when you make your logout request, you will send your cookie with the logout request automatically, then the server will see that cookie, it will find the session associated with that cookie inside of the database, and it will remove that session from the database. It will also tell your client to remove that cookie, and the client will do so automatically. And that is pretty much it. These are the 4 flows that you need to know, and these are basically your cookies and your session objects. Now, before we jump into development, I want to show you how cookie-based authentication works in practice. So basically, here we have our login screen, and essentially here we have our database. So basically, here we have our sessions and their users, and the goal is to see how the sessions and the users collections change once I actually authenticate. So let's begin by simply reloading the page. And before we do that, let's right-click somewhere and go into Inspect. And now we want to go ahead and open up the Network tab. And from here, we're just gonna reload the page, and you will see that there is a request called isAuthenticated, and this request essentially tries to see whether we are authenticated. So basically, at this point in time, we are not authenticated, so the server returns an unauthorized. However, since we've made the request to the server, a session will be created for us. So if I go into my sessions collection, and if I reload this collection, as you can see, a session has been created for us. At this point in time, the session in question only contains my cookie configuration. Inside of our cookie configuration, we can see the max age of the cookie and when it expires. We can also see a few additional parameters, like whether the cookie is HTTP only and whether we're using HTTPS. So basically, in this case, this is all the information we have. Up here, the session has an ID. So basically, once I access my server by making a request, the server will generate a session for me. Now, this session is not associated with any user, but at this point in time, this session is associated with my browser. So basically, right now, if I go into my request here, the server has issued me a cookie. So this cookie essentially comes from the server and it was issued to me as a response to my initial request. And basically, as a result of that, this cookie was generated in the database. So essentially, once I first make a request to the server, it creates a session for me using a cookie. Then if I reload this page, and if I go into this request again, you will be able to see that no new cookie has been issued, and this is because we're essentially reusing the previous cookie. So basically, at this point in time, we're reusing an existing cookie every time we reload the page. Now, for the purpose of a demonstration, I have cleared my cookies and I have cleared my database again. And at this point in time, I've made a new request. And as you can see here, I've been issued a new cookie. So basically, at this point in time, if I reload my collection here, you will be able to see the new cookie. Now, since this was my first request, and I did not have any cookies issued to me before, as you can see inside of my request headers, there is no cookie. But if I reload the page right now, and if I go into my request again, you will be able to see that no new cookie has been issued. This is because if I scroll down here, you will be able to see that I'm providing my existing cookie, and the server and the session manager can see that. So basically, both the server and the session manager know that I am providing an existing cookie, so no new session is created. Now, if I go ahead and delete this cookie from my browser, so basically I can just go and delete all of my cookies and reload the page, you will be able to see that a new cookie will be issued to me. Now, if I go into my database, and if I reload this collection again, you can see that a new cookie has appeared. This is because my previous session was associated with my browser through the cookie that I've been issued when I first made this request. Since I deleted that cookie, and since I didn't send that cookie to my server when I made this request, basically the server saw that I did not have an active session and it created a new session for me. So thus, I was issued a new cookie through the setCookie header. So at this point in time, if I go into my application here, and if I go to cookies, you'll be able to see that I am issued a new cookie. With that said, we know that the server is going to issue a new cookie to every single user. While the cookie exists, no new session will be created unless the previous session expires. Now, if we go back into the database, you will see that each session has an expiration date. So basically, in this case, these sessions will expire at some point in time, and basically, if this happens, the user will need to be issued a new session. Now, it is worth highlighting that basically, since the previous session is not associated with any user anymore, it will remain in the collection until it expires. So to illustrate this a little bit better, let's go ahead and let's actually create a new account. So I'm gonna go ahead and quickly register, and now I can click on sign up, and this simply completes a sign-up request, which will create a new user for me. So this does not impact the session in any way, I just registered a new user, and now with the new user registered, I can actually log in. So let's go ahead and let's sign in using our credentials. And now if I go ahead and if I click on sign in, you will be able to see that I've successfully signed in. So basically at this point in time, I have successfully signed in, and on sign in, I provided my existing cookie. So just like with every other request, when I'm contacting the server, I'm providing my existing cookie here. So now if we go back here, if we go into sessions, and if we reload this collection again, you will be able to see that one of those two cookies got modified. So this is our first cookie, and it belongs to the session which was never associated with any account. So since we've abandoned this session, it will exist until it expires. On the other hand, this is the cookie which we just used to authenticate, and if we scroll all the way down here, you will be able to see that we've appended a new user object to our session. So basically now we have our cookie here, and we have an associated user object. So basically this is how cookie authentication works. When you first make a request to the server, you're issued a new cookie which is associated with the session, and then once you log in, you associate your user information with that session. Now if I log out and if I reload this collection again, you will be able to see that my session was deleted. This is because I explicitly stated on the backend, aka on my server, that I want my session to be deleted upon logout. So basically now, if I go ahead and reload, I will be issued a new cookie once again. So if I go back to my collection and if I reload again, I have been issued a new cookie. So for now, let's go ahead and delete the initial session, we don't need it anymore. And let's go ahead and let's actually sign in again. And I want to show you something very interesting. So right now, if we reload the page, as you can see, we're successfully signed in. This is because we have a session associated with our user. Now, a benefit of cookie-based authentication is that we can simply go ahead and delete the session. So I can go ahead and remove this document. And now if I reload the page, I will be signed out. This is because I'm destroying the session, which is essential to keep me logged in. And basically this is one of the major benefits of cookie-based authentication. The server is actually in control of issuing your cookies and sessions as well as destroying them. And this allows the backend to have full control over all of the users. So hopefully this illustrates cookie authentication pretty well, and with that said, let's jump back into development. If you want to follow along in this video, the first thing you want to do is to download MongoDB shell. Now you can do that by going onto mongodb.com/docs/mongodb-shell, and then you can click on download. From here, you want to select your operating system and the type of your package. For Windows, I'm going to select MSI, and then we can click on download to download the corresponding package. Once you run the executable, this will prompt an installer, and you can simply click next, and then next again, and then install, and this will basically install MongoDB shell onto your system. Next up, you want to go to mongodb.com/drive/download/community, and here make sure you're in the community server section. And from here on, again, you can select the type of your operating system, the package type, and press download. After running the installer, you will see this screen. You have to agree to the license agreement. Then you want to click on complete for a complete installation. Here, as you can see, it's going to tell you the location of your data directory and of your logs directory. And be sure to remember where this is. And then we can just press next. And as you can see here, there's an option to install MongoDB Compass. And since it is already installed on my machine, I'm just gonna remove this checkbox. But for you, you want to leave it as checked, and then you can press next, and then install. Afterwards, you can press on finish. Now, if you're on Windows, you want to open up your environmental variables, And then you can go to environmental variables, and then we can scroll down, and in here we want to go to path under the user environmental variables, and we want to double click that, and we want to scroll all the way down. And as you can see, we don't have an environmental variable for MongoDB here, so we can just simply click on new. And in here, we will need to paste the path to the bin folder of our MongoDB installation. Now, if you're on Windows, you will be able to find this folder and this path. So we have program files, then MongoDB, then server, then 7.0, and then bin. And as you can see here, we have the mongod.exe, and this is what we care about. So we want to copy this path, and then we want to open up our environmental variables again. We're going to press new, and then we're going to paste the path. And with that, we can click on OK, and then we can close these windows. Now, if you're on Windows, you can press Windows and R, and this will open up this window, and you want to type services.msc, and you can press on OK. And this will open up the services screen, and in here, if we sort by name, we should be able to find the MongoDB service, which is right here. As you can see, it is running, and the startup type is set to automatic, and obviously you can change this to be manual, etc. So with that said, we can manually stop and start the service from here. So in this case, let's set this to manual, and let's press OK. And now we want to stop the service, which will shut down the MongoDB service. And now we want to open up a command line tool in administrator mode. And from here, we can just say net and then start and then MongoDB, and we can press enter. And as you can see, the service has started successfully. Moreover, if you go to your task manager, you can see the service running right here. Now to stop the service, you can similarly just say net stop and then MongoDB. And as you can see, the service is no longer here. Now for the case of demonstration, I have uninstalled MongoDB and I have returned to the installer, and now I'm going to uncheck the install MongoDB as a service. I'm just going to say next, and again I don't want to install MongoDB Compass, and I'll just say next again and then install. Now since we have not installed MongoDB as a service this time, we will need to run it manually. To do that, we will open up another command line tool as an administrator. And in here, we want to say mongod and then --db path to specify the path to our data folder. And in here, we want to open up double quotes, and then we want to paste the path to our data folder. And then we want to close the double quotes, and then we want to press enter. And this will essentially start the MongoDB server. Now, next up, we want to open up MongoDB Compass. And from MongoDB Compass, you can simply connect to this default URI. So we can click 7 connect, and this allows us to assign a name to our connection. And now we can click 7 connect. And as you can see, we have connected to our database. So now in the databases section, we can create a new database. So just click on the plus icon. And in the name, you can name it whatever you want, but in this case, I will just name it Code Deck. And in here, I will create a new collection called users. So this will be the first collection inside of my database. And I can click on create database. And as you can see, here is my database, and here is my collection called users. So with that, just make sure that your service is either running from your console or as a service, and we can jump into the video. So let's begin by looking at our project structure. Now in here, I have my Angular client and a Node.js server. So let's jump into the Node.js server and let's take a look at our backend. Now you can find all of this code in the description of the video for both the client and the server. Now here I have opened the server in Visual Studio Code, so let's take a minute to look at the project structure. Now first of all, I have a folder called middleware, and in here I have a single piece of middleware which checks whether the user is authenticated. Next I have a models folder which contains a user model which will be used for MongoDB to create new users. And then I have a Node modules folder, which is automatically generated when we install any Node modules. Next up, I have a .env file, which contains my environmental variables. Now, if you're not familiar with .env files, these allow you to essentially create what are known as environmental variables. So essentially, you can store sensitive information within those files without directly exposing such information within your code. So let's say that you want to upload your code to some remote repository, and in that case, you would not want to expose such information to the world within your code base. This is why you can use substitutes like this to essentially tell your server to fetch that information from your environmental variables. Obviously, you can create such files on any machine and any environment, and you can place your environmental variables there. So the idea is that you would create an environmental variables file on your machine, but you would exclude it from the code uploaded to your repositories, and then you would create one such file on your server, again not included in any code base, and you would again place your environmental variables in there, and then your server would be able to fetch that information without it being directly exposed in your code base. Next up, we have two automatically generated package.json files, and these are generated automatically when you install any dependency. So now let's break down our server.js file, which does the bulk of the heavy lifting. So first things first, we use require.env.config to load the .env file inside of process.env. This allows us to access our environmental variables like so. Next up, we require a few necessary dependencies here, but we will look at those in a second. For now, I want you to focus on these two constants, which is the user constant, which essentially imports the user model from models. So basically, this is our user model here. And then we also create an app constant, which creates an instance of our Express application, which we use as our server. Next, let's look at mongoose.connect, which essentially uses our MongoDB connection string to connect to the database. And then we also want to check that the connection has been established, and that's why we assign db to mongoose.connection, and this allows us to apply the on and once methods to check for errors or to see if the connection has been opened. Now, once we debug that our connection has been established successfully, we can proceed to use our middleware. Now with Express here, we're going to be using a few pieces of middleware, and the first one is express.json, which simply allows us to parse the JSON format. Next up, we have our course options, which essentially allow the front end, which will be connecting from localhost 4200 to connect to our backend. Without this configuration here, our front end will not be able to connect to the backend and our connection will be denied. And next up, we have credentials here set to true, which is required if we want to send authentication cookies from the front end to the backend. And then we use the course middleware to essentially apply this configuration here with our course. So basically, again, this will allow proper connection from our front end to our backend. Now, next up, we have our sessions middleware, which is used to generate our sessions for us. So basically here, we need to provide a secret necessary to generate a session. And again, we're taking the secret key from our environmental variables. Ideally, this key should be very complex and very secure. Now, with that in mind, we're also turning resave to false, which allows us to avoid resaving sessions that have not changed. Again, just like we've mentioned before, every single time a user makes a request to the server, if there is an existing session, then the server will know that the client that is trying to connect already has an existing session. So basically here we're telling the session management middleware that we do not want to resave existing sessions. Then we have save uninitialized, which we set to true to save new sessions. And then we have the store property here, which is very important. Now, by default, the sessions middleware will store your sessions inside of your memory. However, for persistence, we do not want to do that. We want all of our sessions to be stored inside of our database. This will essentially create a new database table for our sessions. And just like we've mentioned before, every single session will have a cookie and every authenticated session will have a user object associated with it. And in here, as you can see, we can set the expiration time for our sessions, and we can also set the URL for our MongoDB, which is the MongoDB URI, which comes from our environmental variables. So again, we are providing the MongoDB URI both in here and up here when we're first connecting to the database. So basically, that's the idea here. And then we are essentially configuring our cookie object. So in here, this is the configuration for our cookie, and we're setting 3 parameters. The first one is secure, and it is set to auto. Now, if secure is set to true, it will only allow this cookie to be sent over HTTPS. If it is set to false, it will allow the cookie to be sent over HTTP, and if it is auto, it will automatically detect the type of connection, and then that cookie would be allowed to be sent through that type of connection. However, be very careful, because if the cookie was created using an HTTPS connection, then this setting will be automatically set to true, and you will not be able to send that cookie through an HTTP connection. Now here you have HTTP only, and this is a crucial setting for security. If this is not set to true, then malicious agents will be able to have access to your cookies using JavaScript. Now, if this is set to true, your cookies will only be accessible when sent through an HTTP or HTTPS connection. Lastly, we have max age, which determines the maximum age of that cookie in milliseconds, just like before. Now, obviously there are more parameters which you can set for both your cookies and your session store, but these are very well documented, so you can look them up manually. Now, having that said, let's move on to the actual endpoints. So first we have the registration endpoint, which is pretty simple, and as I've mentioned before, it does not involve any cookies. So we simply get the username and the password, we check if the user already exists by taking the username, and if the user exists, we return an error saying that the username is taken. Otherwise, we create a new user, and to do that, we simply say new and then user. And again, user here is the user model which we've created up here, and then we say user.save. Now, if we go into the model itself, you will see that we're using a standard Mongoose schema to set a username and a password for the user object. Now, the interesting part is here, because we're saying that on save, we want the password to be hashed using bcrypt.hash, and this will allow us to avoid storing passwords in plain form. So all of the passwords will be hashed for us, and this will make it impossible for any intruder who gains access to our database to see these passwords in their plain form. So again, when we say .save here, this will actually trigger this method here, and it will hash our password for us. So basically, that's the user model here. So again, we're simply creating an object with a username and a password here. And up here, we're also specifying that the username should be unique, and that both username and password are required when we're calling the .save method here. So after registration is successful, we simply return it to the client, otherwise we send an error. Now next up we have our login endpoint, which is a little bit more complicated. Now first of all, we're taking the username and the password, and we're getting an existing user using that username. So this will fetch a user, and then we're saying that if the user doesn't exist, or if the password that we're providing does not match the password on that user object, then we send an error to the client. Now again, this password here will be a plain password, and bcrypt will hash that password for us, and then it will compare it to the already hashed password inside of our database, aka on our user object. Again, the user object here is fetched from the database, and the user object will have a password that is hashed, since when we saved the user, we hashed it at save time. So basically, we're hashing the new password, aka the newly obtained password, and we're comparing it to the existing password. If any of these two conditions fail, we send an error to the client. Now, if none of these conditions fail, we have a fall-through scenario in which we want to create a user object and store it inside of our session, just like we discussed before. So basically, the request.session object here will be attached to our request based on our cookie, and this will be done automatically by the session's middleware when the request comes in. So basically, the request comes in, the session's middleware checks our cookie, and if there is a session associated with a cookie, the session will be placed into request.session. Then, if we want to modify the session, we can do it straight away. So for example, here we want to create a users object inside of that session. So we can say session.user and assign pretty much anything in here. So in this case, I want my user object to have the user ID from the database, and then to have the username of that user as well. So basically, this is how I create a new user object within my session and how I set it to whatever I want. Now, at this point in time, this session here is not saved. Although I've modified the session on my request here, nothing has been written to the database and the session's middleware doesn't know that I did that. Once I respond, however, so once I send a response to the client, the session's middleware will be triggered again. It will check the existing session, it will see that it has been in fact modified, and then it will save it again inside of my database or my store defined in here. This is why we have resave turned to false, because we don't want to save sessions that haven't been changed, but if my middleware sees that this session has been changed, aka if I assign a new object for it, for example, like the user object, then this session will be saved again into the database in its modified form. So basically, to reiterate, in here, we're modifying the session, and then we're responding to the client with an arbitrary response. At the time of the response, the session's middleware will save the modified session to the store, which is our database here, and this is how we associate a user with an existing session. And again, I want to highlight the fact that this is not being sent to the client. We only send a positive response to the client, and if the client doesn't already have a cookie, we will also send a setCookie header to the client to set the cookie. However, assuming that the client already has a cookie and the session associated with it, we're only sending a positive response to the client, and the only thing that our login changed is that it modified the session inside of our database. So this is what our login did. It provided a positive response to the client and it modified the session inside of our store or our database. Now next up we have the logout function. Now in here we're essentially destroying the current session. So basically when this method is called, it removes the session data from the store or database and deletes the session object from the request. This action essentially invalidates the session on the server side. Now the client does not know that the session has been destroyed, but in essence the cookie stored on the client becomes obsolete since it is no longer associated with any session, which allows us to log out the user. Then down here we have a custom function which is called delete, which deletes a user. Now the only reason I've added this function, although we're not going to be using it in our project, is to demonstrate how you can authenticate a user and how you can check whether the authenticated user has the role you require. So basically the idea is very simple. When a request comes in, for example a delete request for a specific user, we need to include a middleware which is called isAuthenticated. If we go onto that middleware simply checks for an existing session and it wants to make sure that there is a user associated with that session. Then, if this is true, we can proceed, otherwise we return an error to the client. Now, if there is an existing user, then this user will probably have some sort of ID. So if we go up here again, the user object will always have an ID and a username. So basically this ID is a database ID, so I can simply say that the admin here is a user which can be found by using database ID in here. So this is why I'm saying user find by ID, and then I'm providing the ID which I fetch from the existing user object associated with that session. So at this point in time, I will have a user object which I call admin. Now in here, I want to check two things. First of all, I want to check that the user here exists. So I'm saying if not admin or not admin is admin. So in this case, we would need to extend our model. Then in here, for each user, we would need to have an additional option called isAdmin, which would be false by default. And then if someone is in fact an admin, we can check that by saying admin.isAdmin. So if the user which we fetch does not exist, or if they are not an admin, then we say unauthorized. Now next up down here, we want to find an existing user and delete that user. Now the ID of the user we want to delete is in the parameters up here, so we can simply say request.parameters.id, and this will find that user for us. If the user does not exist, we inform the client that the user was not found. Otherwise, we simply say await user.remove, and then we inform the client that the user has been deleted successfully. So this is how you can both check if the user is authenticated and retrieve the actual role of the user. Obviously, if it is more convenient, you could have a field in here called role instead, and then the default role could be user, and then in here, instead of saying not admin dot is admin, you could just check whether the role of the user is actually admin. So here you would say if the role is different than admin, then you would say unauthorized. So basically this is how authentication and authorization would work using cookies. So having that said, let's move on to the final function here. And this method is called isAuthenticated. And basically the idea here is that we want to make a simple request to the backend. And then all we need to do is to trigger our authentication middleware to simply check whether a user object exists on our session. And again, if so, then we proceed. Otherwise, we throw an error. And if we indeed have a user object on our session, then we send a positive response like so. And we're saying that the user here is in fact authenticated. And basically this is everything you need to do to set up a very simple but functional server with cookie-based authentication. So first of all, we want to go ahead and we want to start our server. So you want to open up a new terminal, and from here you just want to say node and then server.js, and then you can run your server. And as you can see, we have successfully started the server and connected to MongoDB. And as you can see, my Mongo is running in the terminal here. So now let's close the server and let's open up our Angular project. So now we're inside of our project, and if any of this seems confusing to you, I highly recommend watching my Angular crash course for beginners, because this video is going to cover authentication rather than any Angular specifics. So with that out of the way, let's jump into the project structure. Now, first of all, I want you to open up a terminal and start the project. All of the project files will be included in the description of this video. So basically from here, we want to say ngserve, and this starts a local development server. And if we go into our browser, as you can see, here is our application. So our application will have two paths, the first one being /auth, which stands for authentication, and the second one is /home. Now in here we have a simple form with two fields and two buttons. Now obviously when you want to sign in, you simply enter your username and password in these two fields, and then you click on the sign in button. If you want to register, you can click on the don't have an account button, which will switch the mode to registration. Now this same view is used for both sign in and registration, and the only thing that changes is the functions that we call based on the view that we're currently looking at. So basically here the idea is that the user will first register and then they will sign in with their account, which will create a cookie-based session on the backend. After that, when the user signs in, they will be redirected to the home page from which they can simply log out. So with that said, let's jump back into our project and let's explore the project structure. Now, first of all, we have the application module. The application module will contain declarations of all of our components and all of the necessary imports. Then we have the application component, which at the moment is empty, and the application component obviously consists of the HTML file, the associated CSS file, and the TS file. On the side of the HTML file, here we have our router, which will essentially output the component based on the route that we're viewing. We have our logo up here, and then we have a footer down here. So basically this brings us to the router, which at the moment only has 3 routes. The default route automatically redirects you to the home path. So basically once you access the default route, you will be automatically redirected to home. In addition to that, you also have the authentication route, and by default, if the user has not been authenticated, we will create a mechanism to redirect the user from the home page to the authentication route. So basically, any unauthenticated user will be only able to see the authentication route, and they will not have access to the home route. So with that said, let's take a look at the home component and the authentication component. So if you go into the pages section, you will see 2 components here, and these are basically simple scaffolds. So in here we have the necessary HTML, but the code itself is not that fleshed out. So we're going to be building the sign in and sign up functions together. So going back to the HTML, as we saw before, we have a simple form with 2 fields and 2 buttons. Now in our component.ts file, we have a boolean called register, which dictates whether we're on the registration page or the login page. Beyond that, we have a form group here with a username and a password, and both of these are required. Now, if we go back into the HTML here, you will be able to see that we're using our register variable to decide which function to call on submit, and we're also changing the text on the page based on the current view that we're looking at. So to recap, if registration is set to true, then we call the signup function when we click on the register button, or if the registration is set to false, we click the sign in function when we click on the login button. So basically the idea here is that we have a single view and it is controlled by this boolean here. And again, our inputs are connected to our form group here. So basically we have the username and the password controls here, and we are providing these 2 controls to our input fields via the form control name property. This allows us to directly connect these 2 fields with this form. And we're going to be using this very form to both register a new user and sign in an existing user. Now on the side of the home component here, we only have a single button which calls the logout function. Again, at the moment the logout function is empty, but we're going to be building it together. Now the last thing we want to look at is the services section. Right now we only have a single service in the services section, which is the API service. Now the API service is in charge of making HTTP client requests to the backend using REST API calls. So basically here we have a post request and a get request, and we're using these 2 functions to obfuscate these requests as much as possible. So in the case of a post request, we want to be able to provide a URL and a body, so for example the credentials of a user, and then we want to be able to send that to our backend server using our HTTP client, which is imported from Angular Common. So basically, the HTTP client here is doing all of the heavy lifting for us, and we're simply utilizing the HTTP client to make these two requests. Now, if we click on one of these functions here, you will be able to see that we can provide options here, and more specifically, we can provide an option called with credentials. Now, this option is crucial for us since we want to actually be able to make backend calls with cookies included. So basically, with every post or GET request, we want to be able to include the cookies stored on our browser. Now, the way to do that is to set with credentials to true, and this is a security measure which explicitly tells your browser that you want to send your cookies alongside with any request made with these calls. So basically here we're specifying that we're okay with sending our cookies to the backend server with each request. So to recap, we have two methods, a post method and a get method, and each one of these methods is invoking the corresponding HTTP client function, and it includes the appropriate URL structure here alongside with a body, and in here we're explicitly stating that we want to include cookies with our requests. So basically up here, as you've noticed, we have our base URL, which is used as the base URL for both of our functions here. So we know that our server is running on localhost 3000, and this is exactly the base URL that we're using. Now in your case, obviously this will be different, especially if you're in a production environment. You may want to add your base URL to your environmental variables, and that will allow you to have a dynamic base URL, and furthermore you can even make multiple configurations with Angular and have different base URLs with different builds. Since we're on the topic of services, I want to create another service which is going to be the final service in this project, which is going to be the authentication service. So basically, let's go ahead and let's open up a new terminal, and we want to say ng, then generate, and then we want to specify that we want to generate a service in the services folder, and it's going to be called auth, which stands for authentication. So now the service has been generated, and in here I want to import my API service. So now with the API service imported, we need to define a few functions. So with that done, let's go ahead and let's add a few functions here. So basically these are going to be our functions, and we can actually break them down. So first of all, we have the sign-in function, and in here we're defining that it takes a credentials object as an input, which essentially comprises of a username and password. So then we're using the API service to make a post request to /signin on our server, and we're including our credentials here. Next up, we're doing pretty much the same thing here to sign up. We're again including our credentials here, and then we're calling the post method with a different path. So this time we're calling the signup endpoint, and we're including our credentials once again. Now for logout, we're going to be using the same exact approach, but this time we're going to be using the /logout endpoint with an empty body. And lastly, we have the isAuthenticated method here, which makes a GET request at the isAuthenticated endpoint to determine whether we're currently authenticated based on our current session. So at this point in time, we have a way to actually contact the backend and determine whether we're authenticated or not. Now again here, if we go back into our routing module, you will see here that we don't have any mechanism to essentially decide whether the user is authenticated or not. So basically we need to build such a mechanism, and the easiest way to do that is by using an auth guard. Now an auth guard can be added to any path such as the home page, and then it can determine whether we're logged in or not, and if we're not logged in, it can redirect us to a different path. So let's go ahead and let's generate a guard, and in this case I'm gonna say ng generate just like before, but this time I'm gonna say guard, and it will be in the guards folder, and I'm gonna call it simply auth. In here, this allows us to select a few options, and you can select them by using the spacebar, but we will stick to the first option, which is can activate. So I'm just gonna press enter, and this will generate my new auth guard. So let's go into the guard itself, and as you can see here, this returns true by default. Now we obviously don't want that, and actually we want to be able to tell whether the user is authenticated. Now to do that, we're gonna import, and more specifically we're gonna inject our authentication service. So we're just gonna say auth service equals to inject, and then we're gonna say auth service like this inside the parentheses, and then we're gonna say as auth service. And we also need to import inject here. So let's just do that, and we're importing inject from Angular core. And now we have our authentication service imported. Now beyond that, we will also need our router service, which comes from Angular. And in here, we simply need to import router from Angular core. And be careful not to import it from Express accidentally. So now our auth service and our router are imported. And now after injecting our router, we can go down here and we can do the following. So basically here we're utilizing RxJS, and if you're not familiar with RxJS, I do recommend watching my RxJS course on this channel. So basically here we're saying that if the user is authenticated, and we're using a pipe here, which is an RxJS pipe, and it's going to act upon this observable basically. So we're using a pipe here, and we're saying that we want to return true if everything went well. So if there has not been an error, then we're going to return true. But if we caught an error, then we're going to redirect to auth, and then we're going to return false. So basically the idea here is that we're going to get an error from the server if the authentication has failed. And in this case, we're going to actually return false and navigate to auth. Otherwise, we're going to return true, which is going to allow us to basically view our homepage. So if we save that, we can go back to our browser. And as you can see here, we're on the authentication page. But if I try to access the homepage, as you can see, we're being redirected back to the authentication page. So basically, this works as expected. Now, just for your information, this mapping here would return an actual response. So maybe you don't want to handle authentication with an error, and maybe you get some kind of status within your response. Now in that case, you can simply say if, and then you can say something like res.is authenticated, and then you return true, and otherwise you would do the same as you do down here. So basically the idea here is that in general, in here, you can handle pretty much any response from the server, and down here, you can react to any errors. So basically, in our case, we're gonna leave everything as is, and we're gonna save our authentication guard. And with that, we're ready to start working with our two components. So we will begin with the home component because it is much simpler. And in here, the only thing we need to do is to fill in this logout function. So basically, we already know that we have a simple button here, and when we click this button, we want to log out. So let's go back to our component here, and in here we will need to import our router and our auth service. So the auth service will be imported from services, and the router is going to be imported from Angular/router. Again, be careful not to import the express router by accident. So with that said, we can go into the logout function, and we're going to be using this structure. So in here, in this case, again, we're saying subscribe. So we're not using a pipe in this case. We're simply saying subscribe. And then here, this is our subscription observer. So basically we're saying next. So if the request was successful, we want to redirect the user to /auth, while if there has been a problem, we want to display the error in the form of a log. So basically we can save that, and now our homepage is pretty much ready. So Now, before we can test our home page and before we can test the logout functionality, let's go ahead and let's implement our login functionality. So in here, just like before, we will need to import our router and our authentication service. So let's go onto a new line and let's say private, and then let's say auth service, and then let's import that, and we're going to be doing the same for the router. So next up, we will need to fill in these two functions similarly to how we set up our logout. So first of all, in here, we are using a form. So this means that every single time we submit, we're gonna receive an event. Now, this event will by default reload the page, and this is why we want to do an event.preventDefault call here to ensure that we're not reloading the page every time we submit the form. Now we want to do the exact same thing down here, and now we can actually flesh out our functions. So this is how our signup function looks like, and basically in here we're simply invoking the signup method from the authentication service. Now in here we are saying this.form.value to automatically convert this form into a simple object with a username and a password. Now if I click on this method, as you can see, this is exactly what we're expecting. Now basically here I'm using .subscribe to subscribe to this observable, which will initiate a backend call, and then if the call was successful, we are going to set register to false, basically bringing us back to the login screen, and this is how our function looks like. So basically here I'm calling the signup function from our authentication service, and I'm providing the value of our current form as a parameter. So basically by saying this.form.value, I'm converting this form into a simple object with a username and a password. And if we click on our signup method, this is exactly what we're expecting. So going back in here, then I'm essentially subscribing to this observable, and again, this will essentially call API service.post, which will in turn call HTTP client.post, which returns an observable. So for this observable to essentially make the backend call, we need to subscribe to this observable. So this is why I'm saying .subscribe here, because I'm subscribing to that observable, and then I'm getting the result of that subscription. So next here will trigger on success, and error will trigger if something went wrong. Now on success, this means that we've successfully registered, and this means that we can switch back to the login screen. To do that, we can simply set register to false, since we are already on the authentication screen. Now let's move on to sign in, and unsurprisingly it is almost identical. So basically here the only two differences are that in this case we're calling the sign in method here, which returns the respective observable, to which we're subscribing once again, and in here, instead of changing the state of register, we're navigating to /home, since this essentially assumes that we've successfully signed in, and then home should be accessible to us. So if we save this, and if we go into our web application here, we should be able to both sign up and sign in. So let's open up our inspector here to view the network tab, and we're gonna switch over to fetch requests, and I'm gonna sign up, and I'm gonna say admin here with the password being set to 1234, and I can click on sign up, and as you can see, sign up was successful. Now I can use the same data to sign in, so basically let's click on sign in, and as you can see, is authenticated has returned true. So we've successfully signed in, and as you can see, we already have a cookie. So now we can reload this page, and as you can see, we're still signed in. So basically, as you can see down here, we're using our existing cookie, which belongs to our existing session, to stay signed in. Now to wrap this up, we need to fix two things. So first of all, as you've noticed, when I sign up, the form doesn't reset, so it basically still contains my credentials when it transitions to the sign in form. Now to reset my credentials, all we need to do on sign up is to actually go up here and say this.form auth.reset, and this will automatically reset my credentials. Now, the second problem is less obvious. So let's go ahead and let's sign in again. So let's say admin and let's enter our password and we will successfully sign in. However, if we go to the previous screen, it will still be accessible, although we've already signed in and we have an existing session on the server. We have nothing preventing us from staying on the auth screen. So basically we need to ensure that we cannot be on the auth screen if we're already signed in. Now to achieve that, we need to first go back into our router, and in here we can actually add our auth guard to the auth path as well. But right now it will not work properly since it simply checks whether the user is authenticated. To make it work properly, we will utilize the route from up here. So basically we want to check for the auth route. So we're going to say if route.routeconfig.path equals auth, and then if this is the case, we're going to have a different behavior from the latter scenario. And in here we're following the exact logic as before, but we're inverting that logic. So in this case, if we're authenticated, we want to move to the home page, while if we're not authenticated, we want to stay on the existing page. So now we can save that and we can say our app routing module and we can go back into our web application. So now we can try and access our auth page, and as you can see, we're automatically redirected to our home page. Now if we log out, we can only stay on our auth page and we won't be able to access our home page. So that's about it for this video. I hope you've learned something new, and if you did, make sure to like, comment and subscribe, and I will see you in the next one.